Welcome to the ET335 POS Karnaugh maps, also product of the sums and max terms. Okay, here we have our POS Karnaugh maps, and we're looking at standard forms of Boolean equations. So what we have is product of the sums, meaning multiplication of the added, where we're going to have OR gates, addition, feeding into a AND gate, which is multiplication. So the rules of Boolean algebra that we're going to need are A times A equals A times A bar equals 0, A plus 0 equals A, and A plus 1 equal 1. So if we take our equation here and we rearrange it, where we have A times 1 plus B and times 1 plus B bar, these variables are going to drop out. They're contradictory. So they're working the same way as our SOP, and when it simplifies out, we're just going to be with A. Here we have our 3-variable POS Karnaugh map. Again, it's a 2x4. And we're still going to count 0, 1, 3, 2. And these two columns are opposite. And so the module, the map, works the same way as in an SOP. The difference is we're using addition. And here we're going to evaluate for a 0, not a 1. Okay, here we have a 4-variable POS Karnaugh map. And this is a 4x4, and again we're counting 0, 1, 3, 2. Same on the top, 0, 1, 3, 2. So that's, we have contradictory variables adjacent to each other. So again, this map, top and bottom, are going to be contradictory, and side to side is also going to be contradictory, just like the SOP map. Okay, we have our POS Karnaugh map here, and we're going to plot it. This time we need to evaluate it. We need to evaluate it out for a 0. So let's go ahead and get started. So up here we should have a 1, 0, 0. This is going to become a 0, and it should, at 0 plus 0 plus 0 is going to end up being a 0. So we have a 0, 1, 1. Then we have a 0, 0, 0. Then we have a 1, 0, 1. And our bottom one should be, here we have our 1, 0, 0. Then a 0, 1, 1, and then a 0, 0, 0, and a 1, 0, 1. Should be a 0 here. Okay, here's our colorful answer here. So we have red, which is going to be down here, A bar plus B plus C. Green is going to be A plus B bar plus C. Our blue is going to be A plus B plus C. And the magenta here is going to be A bar plus B plus C. And it matches ours perfectly. Here we have a 4x4 POS Karnaugh map, and we're going to plot it. And again, we're going to evaluate it out as a 0. So we're going to have a 1 here, 1, 1, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 0, 0, 0, 1. Let's plot those. So we have a 1, 1, 1, 1. We're going to put a 0 here. Then we have a 1, 0, 0, 1. We're going to put a 0 here. And we have a 0, 1, 1, 0. We have a 0 here. And 0, 0, 0, 1. we're going to put a 0 here. Okay, let's check it. Okay, here we have our colorful answer, and we have red, and it should be A bar plus B bar plus C plus D bar. And blue should be A bar plus B plus C plus D bar. And green should be A plus B bar plus C bar plus D. And our magenta here should be A, B plus C plus D bar. Good job. Here we have examples of map reduction. So if we have a 2 by 4 and we have a pair of 4 or group of 4, it's going to evaluate is A, because B and B bar are going to drop, and C bar are going to drop out. So we're going to end up with one variable. Here, if they're vertical like this, again 4 is going to result in one variable left. So the only thing that doesn't change is C bar. Okay, here are some more map reductions. We have a group of 3. We can't do 3s. We have to have 2 groups of 2. So in here, A bar stays, B bar goes, and C bar stays. And down here we have A bar stay, B stays, and C bar is out because they're contradictory. Here we have a single unit. It's going to be A plus B plus C. Here we have 2, and C bar are going to cancel out. Okay, here we have 4 by 4 map reduction. So if we have a group of 4, we're going to end up with 2 variables because C and C bar drop out, and D bar drop out, and just leaving us with A bar plus B. A group of 2 is going to leave us 3 variables because our D and D bar are going to go away. Here are more 4 by 4 reductions. So if we have a single, we're going to keep it as is. A group of 4, again, is going to drop out to 2 variables. And if we have a group of 8, it will drop out as just 1 variable. So here A bar is the only one that doesn't change. Okay, here we have a 2 by 4 SOP Karnaugh map, and we're going to go through the entire method of reduction. So first thing we need to do is plot it. So here we have a 1, 1, 1, 1, 0, 1, 1, because we're evaluating it out to a 0, and this is 0, 0, 0, so let's plot it. So we have 1, 1, 1, so we're going to get a 0, 0, 1, 1, we're going to get a 0, and 0, 0, 0, we're going to get a 0. Okay, let's go to the next step. Okay, here we have our colorful diagram of our mapping. So let's go ahead and reduce it. So what we have here are these two, and they are adjacent and contradictory. So let's go ahead and circle them. This guy is going to be by his lonesome here. He doesn't, he's not a contradictory adjacent to any of these. So we're going to reduce this. So we've got, looks like A and A bar are gone. So we have B bar plus C bar. And we need to keep our original intact. So we have A plus B plus C. Okay, and that's our final answer. Okay, and here's our colorful answer, and we did very well. Okay, here we have a POS Karnaugh map, a 4x4, and we're going to go through the entire reduction process. So let's go ahead and plot it. And we have a 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 0. Again, we're trying to evaluate out as a 0. So the first one is going to be right here. And then we have a 1, 0, 1, 1, which is going to place them here. And we're going to have a 1, 0, 1, 0. And we're going to be over here. Good. Okay, here we are with our plotted answer. So let's go ahead and reduce it. There we go. So these two are the only two that are adjacent. Okay, this one is going to be left alone, and we need to add him to the equation. And let's put bars up here. Okay, and we'll put a little X there. And this guy is what's going to remain. We have A bar. Looks like B. C bar. And we need pluses. And D is gone because it's contradictory. Good. Okay, here's our colorful answer, and looks like we nailed it. Good job.